Okay, so this is our second lesson on logarithmic expressions. Today we're going to focus on evaluating logarithmic expressions that have different bases. And eventually we are going to use our calculator, so if you don't have that handy, please pause the video and go grab it. In the meantime, you should pause the video anyway and work on these 6 problems. Okay, hopefully you've had sufficient time, you've given yourself time to work on these 6 problems. Let's go over them. Pull our answers up. I have to tell you guys that the slate is not super cooperative this morning, so we might have some craziness going on. Alright, so here we go. Number 1 is 5 squared equals 25. Number 2 is just 7. Number 3 is 1/2 because the square root of 9 equals 3. Number 4 is 3x. Let's talk about that a little bit. We've got log, see what I mean? We've got some scripty going on. We've got log base 5 of 5 cubed to the x. Okay, pretend that's an x. All right, well, what happens here is when we have a power to a power, we are going to multiply our powers. So we're going to go to text. That's going to equal log base 5 of 5 to the power of 3x. So now the question becomes 5 raised to what power gives us 3x? 3x. And there you go. Number 5 should be pretty straightforward. Which of the following is equivalent to log base 5 of 125? That's just 3. And then number 6, which of the following is equivalent to log base 0.25 of 16? It's important to think of this 0.25. Let's see if we can do this without like getting real gross. As log base 1/4 of 16. Because 0.25 is 1/4. So how do I make the 1/4 into a 16? Well, to make 4 into a 16, we're just going to square it. And then to turn the fraction into a whole number, it needs to have a negative exponent. So our answer is D. All right, here are the answers to last night's homework. Pause the video, take a look at them, make sure you are okay, make a note of any questions you may have. And I would say, because we have a half day tomorrow, that lunch is probably going to be the best time to ask homework questions. All right, so today we're going to talk about what we do when we have different bases. What I want you to do is please write down the information you see right here. I need everyone to write down that this is our common logarithm and that this is our natural logarithm. Okay, so yesterday we worked with all kinds of bases. Today we're going to focus in on 2 bases. We're going to focus in on base 10, which is our common logarithm, and we're going to focus in on base e, which is our natural logarithm. So we've got those 2 buttons on our calculator. That's what they stand for. Base 10 is our common logarithm. So pull up my emulator here. Whoops, sorry if I covered that up. I'll put it right in the middle. Well, maybe not. Here's your calculator. If we press this log button, if we turn the calculator on, there we go. If we press this log button right here, that log is actually in base 10. So let's think to ourselves. If we had log base 10 of 100, 10 raised to what power gives us 100? 2. And sure enough, the answer is 2. So when we press the log button on the home screen, we are working in base 10. Now, another common logarithm that we use a lot, I shouldn't use the word common, another logarithm we use a lot is log base e. So log base e is actually going to be this ln, oop, I hit the 7, is going to be the ln button. So, for example, if we did ln of e squared, we would get Oh, we're in pretty print. Oh, well, here I'm going to get 22. 22. Because e raised to what power gives us e to the 22nd? 22. So what I want everyone to do is just grab your calculator and literally use the log and the ln buttons to try these 4 problems. Okay, hopefully you got these 4 answers and that this was like the most easy thing you ever used in your life. So again, just to reiterate, let's see if I can write here without having an attack. If we don't see a log, we don't see a base, we want to remember that this is base 10, and this is base e. All right, so the next thing we're going to talk about is we're going to talk about the change of base formula, because we need to be able to use our calculator if we're not working in base 10. So I want everyone to take a minute and write down the change of base formula. Pause the video if you have to. Okay, so what we're going to do is we're actually going to use a problem we know. We know what log base 2 of 8 is. We know 2 raised to the 3rd power gives us 8. So what we're going to do is we are going to use this formula right here. Let me see if I can copy and paste that, because that would be sweet. No go. No. All right, so here we go. We are going to type this in on our calculator as log base 10 of 8 divided by log base 10 of 2. And we should get 3. So let's grab our calculator. Clear this out. And we've got log base 10 already there of 8 divided by, now notice I closed that parentheses, divided by log base 10 of 2. You don't really have to close the second one. Doop, and there it is. It's 3. So that's pretty handy. Now, I have a little way of remembering this. See how the 8 is bigger? He's the argument. Our 8 is the argument. The 2 is the base. The base, I'm even going to type this down because it's so great. Not there, though. There we go. The argument goes in the attic. The base goes in the basement. So when you're looking at this on your calculator, the 8 is the argument, it goes up top. The 2 is the base, it goes down below. So let's just do a few others that we know. So like for example, we know that log base 16 of 4. We know what that is, because 16 raised to what power gives us 4? 1/2. So what we're going to type on our calculator is log of 4, because that's the argument, it goes in the attic, divided by log of 16. Grab my emulator. Log 4 divided by log 16. You really don't even have to close that parentheses. And there you go, 0.5. So what I want you to do is I want you to practice using the change of base formula and the log button right here, this one, that one, to try 4 problems. Whoop. So this would be number 5, 6, so go ahead and try these. You are going to get crazy decimals. Okay, so let me grab my calculator now so we can go over these. First, we've got number 5 is log base of 30 divided by log of 3. Whoops, I forgot the log. So you should get 3.0. Is this an always on top option? No, you suck. All right, so then the next one is log of 13 divided by log of 4, and you get 1.5850. And then we've got, yeah, this is boring. You glad we're doing this on a snow day? You can't even use the number keys. Divided by log of 2. Oh, I forgot the division sign. There we go. And the last one is going to be log of 10. Make sure you close that parentheses, divided by log of 5. All right, so to summarize, for number 5, you should have gotten 3.096. For number 6, you should get 1.850. For number 7, you should get 4.087. And number 8 was 1.431. Now, for those of you with fancy calculators, and not everyone has this button, I just want to show you, if you dig around in the math menu, I'm going to hit clear, go to math, and you arrow over to number, I think. Nope, I'm a liar. Math, there it is. And you go down to the bottom. See this one that says log base? If you pick log base, and not every calculator has it, you see that it kind of gives you those cute little dotted boxes. I have to be honest with you, I find this to be a pain because it's a lot of arrowing around, and then you've got to like find the right menu, and then you've got to arrow out of the boxes. And I just find it faster to be like log 30, except I hate this calculator emulator, divided by log 3. I think that's just faster, but it's up to you. I want you to understand how to use the change of base formula, as long as you know how to use that, because you might get a question that says rewrite using the change of base formula, and then you're going to get a question wrong and be like, OMG, I can't believe I got such an easy question wrong, and I'll say, ha, I told you so. So that's the moral of the story. All right, we are going to do one more thing, and then I'm going to send you back to your snow day. And that is, we are going to look at some properties. Okay, so everyone go ahead and write down these lovely properties. Okay, so hopefully the ones in green were pretty self-explanatory. Like, if you've got any base raised to a power that gives us 1, that power has to be 0. If you have a base raised to a power gives you that base raised to x, obviously it has to be x. Now, this one is a little trickier. I'm actually going to move these around. Let's move this guy. So, for this guy, what we're going to do is we're actually going to view this black one as an exponential expression. We're going to rewrite it using the Roman numeral 9 rule, and then it'll be pretty obvious why it occurs. So we've got b Okay, where'd you go, though? I bet I put it right in the middle. Yep, there it is. I need this. Come here. All right, so we're going to put this over here. And then it's b to the x equals log base b of x. Wait, I screwed this up. Totally ignore what I just said. It's an exponential. We're rewriting it as a logarithm. Erase. Sorry. Well, that looks weird. This is an exponential. We are going to rewrite it as a logarithm. So the base comes down, and we've got log base b of x, and then this comes across equals that other log base b of x, and we end up with two equal statements. So again, this one is the exponential, and this one is our logarithm. And we can tell from the logarithm that the two sides are the same. Okay, so this is an important property to memorize. It's also pretty easy. The bases don't cancel out. Don't say the bases cancel out. All right, we're going to look at one more property, and that is log base b of any negative number. So I have a lovely example for you. If we have log base b of -4, I want you to think to yourself, obviously, because you're at home, 2 raised to what power equals -4? If you picked undefined, you would be correct. You can't raise 2 to a power and get a negative number. The base is always going to be positive because we don't use negative bases for exponentials because it would lead to functions that are not continuous. You can't take a number, raise it to a power, and get a negative number. So this argument can never be negative. This is going to be an important fact tomorrow when we start graphing logarithmic expressions. What I would like you to do tonight, this is not a long assignment, is I would like you to please work on worksheet 8.4a in your packet, numbers 1 to 24, and page 490, numbers 48 to 55. Here actually is the book page right here. So if you want to pause it and just knock those 8 out right now, that would be a great idea, and then I'll reveal the answers so you can check your work. And then here are the answers for practice 8 also.